Hello, welcome to everyone in this video. This is our lecture number 8. You all know from lecture number 1 to lecture number 7 we discuss about the differential equation solution by Frobenius method, right? And the special case, that is the legendary polynomial, Bessel's function and Hermite differential equation are discussed in this last 7 lecture, right? So if you wants to watch the previous lecture, you can go through the description box, link are given there. From today, that is lecture number 8, we want to discuss that is the solution of partial differential equation. You all know how to form the partial differential equation, that is the function which is depend on the more than one function. Suppose any function f which is the function of x, y and z, more than one function, then we can form the differential equation, partial differential equation. If the function is depends only one function, then it is the total derivative. But in case where there is a more than one function, then we derivative in partial, that is the partial differential equation. Okay, this is the how the partial differentiation can be formed. But in this lecture or in upcoming lecture, we want to discuss the how to solve the partial differential equation, right? The most popular method is the separation of variable. This is the most popular method to solve the partial differential equation. In this class we want to discuss the this method, that is the separation of variable. In the upcoming lecture we want to discuss the special case, that is the Laplace equation in polar coordinate system and its solution. So let's start today's discussion. That is, this is the total syllabus. This section 2 we discuss from lecture number 1 to lecture number 7. Okay, now we want to discuss this chapter, that is partial differential equation. In this lecture, that is lecture number 8, we want to discuss this portion, that is solution of partial differential equation using separation of variable. Clear? So let look at this process. This is the partial differential equation where f is a function of x, y and z. Clear? If there is only one function, then we write df dx like that. But here the f is function of x, y and z. That's why this equation will be in form of del. Del is the notation of the partial differential equation. So here we can take this function is a f is a function of x, y and z. Now in case of the to take as a separation of this variable, we can take that is this function as a function of x, y and z. Clear? So f can be taken as the x into y into z, where x is the function of x, y is a function of y and z is a function of z. Very simple. Now take the partial derivative. If you take this partial derivative with respect to x, you can see here this y and z as the function of y and this is function of z. So this is the constant with respect to x. That's why this as a constant and this will be derivative. Because this is function of only x, that's why we take this is dx dx. Clear? D of capital X, d of small x. Capital X is the variable and small x is the sorry, capital X is the function and small x is the variable. Clear? Why we write d? Because this is a function only x and this is a function more than one variable, that's why this is del. But this is only one depends only one variable, that's why d. So if you take the second derivative, this will be constant, but this will be like that. In the similar manner, we will take with respect to y and with respect to z. So we obtain this value, that value and this value, put these values in this equation number 1. After putting this value, you will be get this equation. Now if you divide it by x, y, z, you can see you will be get 1 by x, here will be 1 by y, here will be 1 by z. So you can see now if you take this in the right hand side, so this is the function of only x and this is the function of y and z. Since this is separate out, this is the separate out, that's why this is called separation of variable. This x variable is separate out. We'll take this as a minus n square, and if you take this one, so minus minus cancel out, you'll be get this. And you know this is the standard differential equation. We already discussed this type of differential equation. By Frobenius method you can solve, this solution will be like that. Otherwise there is another method to solve this type of equation. You can see here I think you learned this thing in class 12 mathematics. That is the if any differential second order differential equation will be like that, you can take this as a series solution, and you, from the previous Frobenius method, you know this is how the differential second order differential solved by Frobenius method as a series solution. So this y has taken as the a e to the power mx. So if you take the first derivative with respect to x, you will be get m a e to the power mx, and take the second derivative, you will be get m square a e to the power mx. Okay, so put this derivative in this expression, you will be get this type of expression, and this is the quadratic equation, and whose solution will be like that. If these roots are m1 and m2, depending upon the nature of this m1 m2, the solution can be written directly as like that. That is, m1 and m2 are real and unequal, then the solution will be a to the power m1x plus b to the power m2x. But if m1 m2 are equal, real and equal, then we can take this a plus bx into e to the power mx. And third case, when these m1 m2 are complex conjugate, then complex conjugate means there will be a real part, there is an imaginary part. Take real part as like that, imaginary part is a cos beta x, b sin beta x. I think you know all about this solution. So you can see here, for that for that there is a minus, so this will be like that. If you take this one, you will be get this will be the my plus omega minus omega, that is the a to the power omega x, b to the power minus omega x. Same thing written as. So you write directly write down this thing just for your information. I write right here like that. Okay, so we got the solution of the first part, that is this portion already solved by this method. Okay, so go to the next one, that is this 2 equals to minus n square. If you this is equals to minus n square, so this is in the right hand side, you will be get this one. Take this as a m square, separation of constant, so this is m square, same thing, this will be like that. And this one is written as like that, and take this minus b square, the solution will be like that. So the total solution is nothing but the product of this solution, where a b c d e f are the constant which can be obtained from the boundary condition. I think you understand the method of separation of variable by which we can solve the partial differential equation. Clear? Now go to this some example. First example. Look, use this method of separation of variable to solve this equation. So this is a partial differential equation you need to solve with this boundary condition. So since you can see this u is a function of x and t, so that's why we take this u is a function of x and function of t in the product form. Take this partial derivative with respect to x, this will be like that, and partial derivative with respect to t, this will be like that. Here the first order derivative, that's why it only take first order derivative. So put this value in this equation 1, you will be get this one, and this divided by xt will be get 1 by x 1, and this is 1 by t. This take this as a separation constant, so this will be like that. And take the t portion and small t and capital P in the the separated out. Then integrating, you will be get the ln t, and this is kt, and take this constant, so this t equal to a to the power kt. In the take the next portion, that is the 1 by x dx by dx, d capital X by d small x plus 1 equals to k. So take in the right hand side and separate out x and x, and then integrating, you will be get this from x, so you will obtain t, and here this obtain x, so just product them, you will be get this solution. Now we can find out this constant value using this given boundary condition, right? So given boundary condition is like that, at t equal to 0, e equal to this. So put this value t equal to 0, you will be get c e to the power minus e to the power k minus 1 into x. So c equals to 4, and this is equals to k minus 1 equals to minus 3. So k equal to minus 2, and like that. So putting so obtain the value of c and k, put this value, you will be get this solution. I think clear how we can find out the solution of partial differential equation using the boundary condition. Take another example. Suppose this is an partial differential equation given these four boundary condition. Clear? At very first, you just realize the boundary condition. Look, at x equals to L, y equals to y, this u value is 0. That means at x equal to L, that is x equal to L, that every point at x equal to L, this u equals to 0. Next is at x equal to x, y equals to 0. This is f of x. So y equal to 0 means this x axis. So at x axis, this will be f of x. Next, x equals to 0, y varies. That's x equal to 0 means y axis. So x equal to 0 means y axis. This will be 0. And then x equal to 0, y equals to infinity. This will be 0. So these are the boundary condition. So this solution will be within that region. Okay. To infinity. So just to follow up the previous method, that is the u is a function of x and y. That's why you take x a function of x, y function of y. Clear? So take the partial derivative with respect to x and with respect to y. Will be get these two things, putting these two things in here, and just sorry, divided by xy will be get this one. Take in the other side, take in the other side and take the separation constant. So separation constant, so you remember in the plus, so this will be sine and cos, and if you take this positive, this is exponential. I think clear. So the total solution will be like that, just product of these two solutions. Now using this boundary condition, first boundary condition, use the first boundary condition, that is the u x infinity equals to 0. That's mean when y tends to infinity, this u must be 0. So y infinity means e to the power infinity, that is infinity, and e to the power minus infinity is 0. Since right hand side is 0, so this c must be 0. Otherwise, this is the infinity. So if c not equal to 0, if c not equal to 0, then what happen? This part is infinity, that means left hand side is infinity, right hand side is 0. This is not possible. So c must be 0 such that this equation is valid. That means in this boundary condition, we get the constant value of c, which is 0. So if we put this expression c is 0, you will be get this expression with d to the power minus ny. So you can multiply the d with that a into d taken as g, a b into d taken as h. So you just reduce the constant, because there is a possibility to reduce the constant such that we can find out the value of constant. This is no problem to reduce this constant, because this constant into constant just given another constant, right? Now use the another condition, that is the u 0 y, that is 0. That means when x equal to 0, the u must be 0. So put the value of x equal to 0. You can see here in this expression, x equal to 0 means sine 0 0, cos 0 is 1. Cos 0 is 1. I think there is a mistake. This must be 0. Cos 0, cos 0, this cos 0, which is 1. Cos 0, which is 1. Okay. So just put this value cos 0 and e to the minus ny. So you can see this is not 0 and cos 0 is 1. So g must be 0. So you will be get this g equals to 0. So the remaining term will be uxy equal to h sin nx e to the power minus ny. Clear? So you use these two boundary condition and you have remaining another two boundary condition. First one, that is u l y equals to 0. That means when x equals to l, y is y, then this will be 0. So put this value, that is h sin nl. So there is a mistake, sin h sin nl into e to the power minus ly equals to 0. So this, if you take h equals to 0, then what happen? If take h equals to 0, then what happen? If h equals to 0, then solution will be 0, trivial solution. Okay. So there is a opportunity to take another portion, that is this can be taken as 0, and you know sin n pi, or you can say this is p pi. Sin p pi is 0. So if you compare this, n equals to p pi by l, where p equals to 0 1 2 3 etc etc. So the solution will be like that. If you just put this value of n, you can see here, since p is varies from 0 to infinity, so you can take this take the summation of this to get the total solution, because you know the linear combination of each solution also a total, also the solution of total, right? So linear combination of linear linear combination of all solution must be a solution. That's why we take the linear combination. We start p equals to 1, because if we put p equals to 0, this will be 0, so this is the 0. That's why we take p equals to 1. If you take p equals to 0, there is no problem, but in this case this will be 0. For p equals to 1, this the summation will be the total solution. Clear? You have another boundary condition, that's one. So use this condition, you will be get this one. So to find the this coefficient HP, you will be just taking this integral. I think you know about the Fourier series. If you don't know, in the upcoming lecture I will be covered this Fourier series also. At this moment you can see, you in the Fourier transformation or Fourier series, we can find out this coefficient h of p like that. Okay, so this will be the coefficient h p to L by this. So the solution will be like that, where hp equals to this. I think clear about the all the process and how we can find out the constant using the boundary condition. If there is any doubt, you must comment in the comment box. Okay, so this is your homework. Do this in yourself to practice how you can solve this partial differential equation. And this is 1 2 3 4 question, and this is the fifth question. This is an important question which actually we discussed in the another form, but you can solve this question. Calcutta University 2004, this question was asked, and this is question number 6. So I think you can solve this question 6 up to this 6 assignment. If there is any doubt, you must comment in the comment box. So that's it for today. This is all about me. This is my contact details. You can connect with me with this telegram channel, and there is another a group and the same name in the telegram. You can join with us to discuss any physics related discussion. Okay, this is my online platform, and this is my YouTube channel details. Go to this channel, you will be get another physics related lectures, and like this session. If you learn something from this session, share this video to your friends, either he or she also get benefit from this video. Subscribe this channel if you new in this channel, and those already subscribed, thanks for subscription. Press the bell icon to get the notification of upcoming video. In the upcoming video, will be discussed the discuss the solution of the given assignment are given in this lecture. Yeah, so let's try yourself first. After that, you can watch the next lecture to watch the solution of the question asked in this lecture. Clear? So that's it for today. Thank you. Take care. We'll meet in the next video as soon as possible. Thank you.